Have you ever wondered how your phone recognizes your face to unlock? Or how Google translates handwritten text into digital words? All of these technologies use convolutional neural networks, or CNNs, a special type of artificial intelligence that helps algorithms see and understand images in a way like humans do. So why are CNN important in everyday life? They help us with face recognition, like unlocking your phone with your Face ID, self-driving cars, recognizing traffic signs, medical imaging, detecting diseases in X-rays. But how does an algorithm learn to see? For us, recognizing a number or a face is easy, but for an algorithm, it takes layers of learning to figure out what it is looking at. Let's explore how a CNN works using candies. Look at these black candies. They have formed a number. For you and me, as humans, it is easy to see that this is the number 2. But how does an algorithm learn to read it? Let's break it down step by step. A CNN processes images in layers, just like peeling an onion. Each layer extracts useful information from the image and passes it to the next layer. So the structure of the system is flexible, meaning that we can add more layers or adjust them to make the network even smarter. So the first step is how the algorithm stores images. Before an algorithm can actually see, it first needs a way to store images. And an image is not stored as a picture, but as numbers. Every image is made of tiny little squares called pixels. And in each case, let's say our candy image is 13 by 13 pixels, meaning the algorithm stores it as a matrix with 169 numbers. That meaning a 13 by 13 matrix of 169 neurons. So think of each neuron as a bit of information. So step 2, convolutional layer, like scanning with a magnifying glass. Instead of looking at the whole image at once, an algorithm analyzes small parts one by one using the convolutional layer. Imagine using a magnifying glass to inspect tiny sections of candies. The magnifying glass represents how the algorithm moves step by step across the image, looking at small portions at a time. Each time it detects a black candy, it says, hey, there's black here, it might be part of something bigger. And this scanning process helps the algorithm focus on details rather than the whole image at once. Step 3, feature detection. The kernel identifies patterns. The kernel or filter is a small tool inside the convolutional layer that identifies specific features such as edges, corners, or horizontal or vertical lines. How does the kernel work? Well, the kernel slides over the image just like a detective looking for clues in different sections, and each kernel is trained to detect different features. One may find straight lines while another finds curves. And the more the network trains, the better the kernels become at recognizing shapes. For example, if a kernel is designed to detect vertical edges, it will highlight where there is a strong contrast between black and white, helping the network recognize the shape of number 2. At this stage, the algorithm is no longer seeing individual candies, but recognizing patterns. Step 4. Pooling layer. Keeping the most important parts. Now, the algorithm doesn't need to remember every single black candy, just the most important parts. So what is pooling? Pooling helps reduce the size of the image while keeping the most useful details. It's like taking a blurry picture of a zebra. You don't count every stripe, but you still recognize it as a zebra. So how does the pooling work? Instead of storing every pixel, we keep only the strongest ones, like for example the darkest or most activated parts. And this helps the network work faster and more efficiently. After this step, the image is now just a compact, meaningful set of numbers that still represent number 2. The network repeats the convolution and pooling processes multiple times, making the image more and more abstract. Step 5. The fully connected layer. Understanding the number. So now comes the final step, classification. At this stage, the algorithm no longer sees candies or pixels, it just sees numbers. And how does it recognize the two? Well, the abstract patterns, curves, edges, and dark areas are passed to the fully connected layer, and this layer combines all the clues and compares them with numbers it has learned before. So finally, the network makes a prediction. Yes, the black candies form number 2. So just like you recognize numbers, faces, or animals, an algorithm can learn too. It does this by breaking down an image step by step, learning from patterns and improving with experience. And that's how a convolutional neural network works. With Candy. Thank you!